สวัสดีครับ My name is Chatchanan khamtonwong Student ID 6522771029 I'm here to present our project. Hello everyone, today I will be presenting our smart automate plants water systems. A rapid demo prototype that waters a plant whenever its soil is dry. Then enforce a stimulus 12-hour lookout before rechecking moisture. Over the next few slides, I will cover our motivation and concept, walk through each model component in details, and finally explain the complete circuit diagram. Our motivations came from the fact that houseplants and urban gardens are frequently neglected or overwatered. People either forget to check soil moisture or miss just the right timing. We want a low-cost, easy-to-build system that have first, automatically waters whenever the soil dips below a safe moisture levels. Second, prevents overwatering by locking out further pumps for a set periods. And last one, give instant feedback via a 7-segment display showing that lockout time. By simulating 12 hours at 12 seconds, we can quickly observe the full cycle in a demo environment. Here are our key hardware components. First one, a 5-volt relay module drives a 9-volt mini pumps that relay IN pin. The relay IN pin is on D3 of the Arduino, and the pump's battery's negative is tied to the Arduino ground. Next, the soil moisture modules. We use an LM390 comparators. Its digital outputs or DOs go to AO, letting us detect dry and wet. Next, a common cathode 7-segment display. It will be on D7 pin to D13, show our 12-hour countdown. Next, an Arduino Uno. It orchestrates everything, and we power the pump separately from a 9-volt alkaline battery to reduce load on the board. Let me walk you through the wiring. First, power and ground. Arduino 5-volt and ground feed both the relay modules and moisture modules. The pump battery's negatives also ties to Arduino ground, so that the relay coils had a common reference. Next, relay to pump. Relay comms connect to the 9-volt battery positives. NO or normally open channels go to the pumps that tie with terminals. When the relay is energized or D3 is high, the pump receives 9 volt soil sensors. The comparator boards had VCC and ground connect to Arduinos, and its digital output D0 is read on D6. When soil is below the threshold set by the onboard trimmer, D0 read out low, that means dry. Next, 7 segment. Each segment A through G is driven from D7 to D13 via current limiting resistor on the breadboard. The display common cathode pin is tied to the ground. Next is logic flow. Idles mean the soil is wet. The circuit will do nothing and display 0. Next is dry detected. The relay will be on and the pumps will run. The next one is when moist detected. Relay will be off and it will enter the 12-hour countdown. Display ticks 0 to 11. The last one is after countdown. It's returned to idle and remonitor the soils. In summary, our prototype reliably waters only when needed, avoids overwatering via a time lockout, and provides clear visual feedbacks. In future versions, we could add wireless notification to your phones, or solar panels battery charging, or more sophisticated moisture profiling. And thank you, that's for all my part.
Hello, my name is Nutkumhang, the second member of the group. Next, I'm going to be explaining about the code and demonstrating our model system to you. So here is our coding section. Let me explain it to you line by line. Let's start with the first 2 lines. The first 2 lines is we set the variable to represent our input and output pin. The first is for relay pin, which we're going to be connecting to the pin A0 on our Arduino, And the second one is for soil sensor pin, which we're going to be connecting to D6 of our Arduino. This two line is optional though, we just use this for our convenience. And this line right here it represents the delay duration. For the line on the top is for our full delay, which we set to 12 hours, as you can see here, 12 hours per delay cycle. And the bottom is show how long we're gonna be changing the 7-segment display, which is 1 hour. This number are represented in milliseconds, as you can see here. And the next line is we set the variable to represent pin out of 7 segments, which we're gonna be connecting to D6 to D30 of our Arduino. And the section below is the binary number list, which the system going to be converted into integer from 0 to 11. The 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In our model, the system have two states, which is idle and watering. The idle state is represented when the system is accepting input from the soil moisture sensor, and another is watering state, which is the next state after idle state receives input from the soil moisture sensor that soil is dry, then pump out the water. So we're gonna set the default state as idle right here in this line. So next is our setup. The first line is we set the baud rate to 9600 bits per second to match the Arduino rate. And the second line is we set relay pin as an output. As you can see here, relay pin the same as above. And set relay pin default output to high, equal no current right here. And line 27, we set soil sensor as an input. The port is shown here. And in this for loop, we prepare our 7-segment display pin to D7 to D30. This line represents be in output mode, and this line represents start with or segment off. And the last one is we set default to display 0. So let's talk about our main loop. We read input of our soil sensor as a voltage because we would like to, and then we set the delay to 500 milliseconds to prevent hardware crash. This line is important though, don't forget to put this in your code because, as you know, C++ is run very fast. To the point that your hardware may cannot handle it, so we need to set delay maybe 50 or 100, but I prefer 500, which is half of a second. So at the start, we're gonna enter idle stage, which is our default state, and this line shows that if we read the voltage greater than 2.0, soil sensor provide voltage input greater than 2 volts. It means the soil is dry. Then we set relay pin to low. Why do we set it to low? Because our relay pin is the active low. That means when it's low, it allows current to pass to the water pump. That means our water pump we're gonna be working and watering the plant. And then we're gonna change our state to watering. So let's move on to watering state. In this case, if voltage less than 2.0, that means soil sensor provide voltage input less than 2 volts. It means the soil is now being moist again. Then we set our relay pin as a high. As you know, it's an active low, so high means off. That means it's not gonna be allow any current to pass to the water pump, so the water pump turn off. And here is our delay section. So the first line means record the current time in a millisecond, as you can see here. we declare a variable named start and gonna set it equal to function milli. And the second variable we're gonna set to equal to start. Set the last count to the same value at the start. And our count, this value we're gonna be displayed in our segment, our 7 segment right here. And in this while loop, this is a blocking loop that runs until the delay duration 12 hours have passed since start. So the if clause in this here is check if enough time have passed since the last tick. It is a variable that we set here to increment the hour display. So the hour count get plus increment by 1 and make our 7 segment display the updated hour count. And we set a small delay right here. And once the delay is complete, we reset to display 0 on the 7 segment after the delay cycle come to an end. The 0 print delay over, ready for the next cycle. And we reset the state to idle again. So if we on an idle state and the voltage is lower than 2.0, that means the soil is moist right now. The system not gonna do anything. If we're gonna skip this if clause and break. As same as watering. If the water is watering and our soil is still dry, it's gonna keep watering. Okay. So the last one is our segment driver, as you can see here. And that's all for our code. So here is our demonstration. We have the Arduino, which is now connected to my personal computer right here. And next is the relay module attached to our water resource, which have the mini water pump inside it. And here is the 9-volt alkaline battery provide electrical resource for our mini water pump. And here's our soil moisture sensor, which is present inside the plant pot. Let's just assume that this is the actual plant pot for now. And the last one is our breadboard, which 7 segments, which will display how many hours have passed after the last watering. So here in our demonstration, we're going to use time unit as a second instead of hour for our convenience. So let's take a look at our first test case. Let's assume that our soil is moist just right now and one is get dry. The system work and a water pump the water inside it, and when it gets moist again, the water gonna stop watering the plant and the timer will count how many hours have passed before the next cycle. So let's move on to our next test case. Let me run the test again. So as you can see right here, no matter what the soil gets dry or moist within the period of the delay time, the system not gonna receive any input from the soil moisture sensor until the next period begins. So in the final test case, we want to show that after the delay period come to an end, if the soil already got moist, maybe by rain or something, the system's not gonna watering the plant until it gets dry again.